Okay, I thought I was going to get to cover overloading of methods in the last video, but it got to be about 20 minutes long. I'm trying to keep them down. So we're going to continue, and with that last example, I'll show you how to overload methods. And overloading means having two versions or multiple versions of a method where the method has the same name, but it has a different type or number of parameters. So let's take a look at that. Okay, so in the last program we went ahead and we used our Sentinel input example program, and we basically used a method to oh, do I have the right program? Yeah, there it is. Okay, so we wrote this static method getInt to handle the logic of reading a value and rejecting it if it wasn't a valid integer. And so now we're going to add another version of that method, and that's called overloading, when you create two versions of the same method. And so you'll recall before in the video sequence I showed you how to do range checking. So here in our gradebook program, a valid integer grade is 0 to 100, and then the only other valid input is -1. So we can kind of do range checking, and we can say that if the user enters something that's less than -1 or greater than 100, that's invalid. Now that's different than the error checking we're doing now. So the has next int just checks to see if there's a valid number, and it then goes ahead and reads it. And basically what we're going to do is we're going to create a new version of this, and we have to generalize it, we're going to have to pass in the range. So first thing I'm going to do is I'm going to copy the method. Okay, so I got the method. And these methods will be very similar. In fact, you could kind of argue that once we have the new version, we would never use the old version. So the idea here is that the old version will let me get any integer. The new version will require the integer to be within the range that I specify. So let me paste this in. That immediately generates an error because the compiler, NetBeans, says, hey, wait a second, you got the same thing twice. But I can fix that right away by coming through and putting in the parameters. Okay, now since this is reading integers, the parameters, the low and the high, should be integers as well. So we'll say int low and int high. Okay? So now most of this is going to be the same. And one problem we have here is we've set the input value to this. I don't think that'll be an issue though, because it gets redefined. The reason I did that was the compiler can't tell in this conditional code that input value will actually be set in either event. So obviously I coded the logic that it won't leave the code until it gets a valid thing. So here's the deal. If this is true, we got an integer. Now within this block we have to make a second check to make sure that the integer value is in range. And we can do that, and obviously if it's not in range, then we're not done. So that done statement is going to be set up in the new block that we're going to add. So here's how we're going to do this. So if, and then input value is less than low, or input value is greater than high, that means it's out of range. And oh, wait a second, I did that the wrong way. I want to invert that. So let's see now. Let me just think this through. So if you give the low value, so if it's less than low, okay, so this code says it's out of range. So I've just read it. Okay, so right, I got it right. So this is going to be in the else clause. I wonder if you can hear that whistle. That's some weird bullshit with the pipes in this building. Really annoying, especially when it's right in this room. It's down the hall right now. Uh, let's see. Okay, I got a bit of an error here because I did a stupid thing. Let's make that high. All right. Okay, so this is the case, this first one, if it's true, where basically that means that the value is out of range. So I just read an input in, but it's out of range. And so in that case, I want to go ahead and just put an output statement to the user, just like I did down here. And so this message says you got to enter a number. And actually, because I've got the range now, I should probably fix this too, right? So let's go ahead and grab this statement. We'll patch it up in here, and then we'll copy it back over, replacing that. So you could argue that, hey, it's worthwhile, Tom, to have two different numbers. One for when they didn't enter, two different messages. One for they didn't enter a number, one for they didn't rent a number in range. But I think we can get by with one. So you must enter a number from plus low plus 2, we need spaces there, plus high. And then there we go. Okay. That message has gotten kind of long here. Let me just scroll the screen so you can see how that works. So you must enter a number from, and then we'll have the value for low. We have a space before and a space after 2, followed by a space, followed by the high number, and then the period, which because that's the end of a sentence, and then try again. Okay? And then this should be a system print. Yeah, okay. All right, now that's the new and improved error message. And so it kind of, and if you think about it, it's, you know, just more specific than saying you must enter a number. Okay. So in the previous program, though, that was appropriate. I mean, excuse me, the previous version. Because really, we were just asking the user to enter an integer, and we weren't doing any range checking. So the difference between the two is this one now does the range checking. So I got my low and my high. Now, if I come up here into my code, I'm using the old version. And so now I can go ahead and say getInt, and of course low here is -1, and then high is 100. You know what? Let's check and make sure I got the logic right, because we want to make sure that's inclusive. So actually, we want this to be less than or equal to low. Oh, no, that's right. So less than low allows it to be low, and greater than high allows it to be high. So we don't want our programmer to have to fiddle with what the values are. So the actual value that's legal is -1 to 100. The programmer enters that. This says greater than 100, which means 100 would be okay. This says less than -1, which means that that would be okay. Now, you know, before I talked about how I had to set this up, but that shouldn't be a problem, because you see that input value gets overwritten. The -5 would get overwritten with whatever the actual input value is. So this is really just a little trick, because the compiler isn't smart enough to figure out that in every case I've actually set that input value in the logic that I have. Okay, I think we're ready to test. Let's give it a try and see how it works. And so now I have to test several things. First, I should probably make sure it still works. So we'll just do that. 34, 45, 56, 78, 90. That's good enough. -1. Okay, 5 grades, 60. That looks pretty good. All right, let's run it again. And now we'll try a non-number value. So 45, 67, 78, 89, GH. And it says try again. So I'll try an 89 again. And then -1. I should have 1, 2, 3, 4, 5 values, which I do. Looks like we're good. Okay. All right, so now we can try what happens when we put in a number, but it's out of range. So again, whenever you do a testing, you have to think carefully and kind of plan the logic of the test to cover all your conditions. Let's start right out with a bad number. So 101. You must enter a valid number from -1 to 100. Try again. Now, that's nice. I didn't get that little artifact that I had where it repeated. And I think the reason for that is it actually read the number. It's just going to throw it away. So let's go ahead with 23. And then, let's see. Hey, we have to be careful and make sure that we counted this. You must enter a number from -1 to 100. Try again. So 23, that's one number. 34, 2, 45, 3, 56. Let's see. 2, 3, 4. One more. 67. And then -1. Let's make sure. So 5 grades. That's good. So 23, 3 of 4. I'm sorry, 1, 2, 3, 4, 5. Excellent. So it didn't count the 101. That would have thrown off the average. So it's reading correctly. Okay, so you might say, hey, we didn't get much from this. Yeah, we did. It's better. Now it actually prevents the user from entering a value that's out of range. And the important thing here was to show you that we could overload our functions. So we now actually have two getInt functions, and one takes these parameters and the other doesn't. You know what? I forgot to do the Java doc, and you're absolutely forbidden to do that in your program assignments. So let's go ahead and enter the Java doc blocks. This one doesn't have any parameters, so all it has is the return. So the integer value, I could have said int value, entered by the user. Okay, and let's put in a description. Let's see, bullet proofs, user input, looping until they enter an int. Okay, and then we could basically come on down here, and I want to show you that it's always nice to let NetBeans generate this for you because it picks up all the parameters. So notice that it got all the parameters and my return. My return is the same, except that it's going to be in range. It's going to be constrained to be in range. So, whoops, I didn't realize I misspelled integer. Constrained. We can put that in the description. All right, let's do that. So loops. Okay, so first requires the user to enter an int within the specified range, looping until they do so. I probably could have said that better, but that makes sense. It's English. You understand what it means. Okay, now we have to specify what these are. So low, the lower, and it's good to say the lowest valid input value. And notice that's not going to necessarily be -1. That's going to be whatever I specify, right? And then this is going to be obviously the highest valid input value. It might be good to say the lowest valid integer input value. Let's do that. Just to reinforce the fact that it does read ints and not doubles or floats. In point of fact, if the user tries to enter a floating point number, it will read that as an invalid input and it'll reject it. So it won't allow the user to do that. We could probably write a method that reads numbers and lets you read any number, and then if you want an integer, it just basically truncates it by casting it to an integer. Okay, that turned out to be a good choice to make this into a second video. We got about 15 minutes. So again, just real quickly, this process of creating multiple versions of the same method, that is methods that have the same name, is called overloading. And the rule is that the methods have to have a different signature. And so this is the signature. So they have to have a different number or type of parameters. So the first version has no parameters, and the second one has 2 integer parameters. Okay? Now, you can see where we could go with this, right? So I could go ahead and create a get float and a get double. And at that point, I should probably think about making this into its own class. And then I'm going to have an issue. And the issue is that I'm actually using this global variable here. So this really only works, where's my method? Sorry. This really only works when I've already opened and declared this scanner but with this name, okay? So obviously a good option would be to create another real general method that takes the input as a parameter. And then whatever I name the input, I could pass it in, okay? And we could change that real quickly. Maybe I'll do that later on for you, but right now I think we're doing enough. So I showed you how to do the overloading. That was the intent. Okay, once more, I hope you're really enjoying these videos. They're helpful for your learning. And you know what I always say, code on, dude, or do det, as the case may be.